In this video, we're going to talk about percentiles. A percentile is a measure of location. There are 99 percentiles denoted P1, P2, all the way up through P99, which divides a set of data into 100 groups with about 1% of the data values in each group. Where have you heard percentiles? Probably the most common place was at the doctor's office when you went to the pediatrician. You're given your percentile for height and your percentile for weight. For example, one of my children is very tall and he's in the 99th percentile. What does that mean? It means that if 100 children, including him, his age, were all lined up from shortest to tallest, he'd be the last one and there would be 99 kids shorter than him. I have another child who's in the 86th percentile. Well, in the line of 100, there'd be 86% that are shorter than him. There would be 14% taller than him, his height or taller. So the 86th percentile divides the lower 86% with the upper 14% of a data set. How do we find a percentile of a data value? Well, the percentile of x equals the number of values less than x over the total number of values times 100. When it says the number of values less than x, it's important to remember that that's when our data is in order from lowest to highest, also called ascending order. Let's look at an example. The airport Verizon cell phone data speeds listed below are arranged in increasing order. Very important to have your data in increasing order when you're doing a percentile problem. We need to find the percentile for the data speed of 11.8 megabits per second. So let's first find the first place that we see 11.8 on this chart. It happens to be right here. 11.8 is the 21st data value. So we need to find the number of data values that come before 11.8. So if it's the 21st, that means that there's 20 values out of the total 50 values we see in the table that come before 11.8. We're going to take that and multiply it by 100 to get our percentile. That's equal to 0.4 times 100, or 40. So our interpretation of this, the data speed of 11.8 megabits per second separates the lower 40% of values from the highest 60% of values. We have P sub 40, that's the 40th percentile, is equal to 11.8 megabits per second. Now let's find the percentile for the data speed of 77.8 megabits per second. Let's find it in the chart. 77.8. Well, it's the very last one. So what does that mean? It means out of 50 values, there are 49 values that are less than 77.8. 49 out of 50. We'll take that proportion and times it by 100. And what we'll get is 0.98 times 100, or 98. So the 98th percentile, P sub 98, equals 77.8. We just talked about finding a percentile for a given data value, but we also need to go in the other direction. So we need to learn how to convert a percentile to a data value for our particular table. There's a process for this. To start with, we sort our data in ascending order. Next, we have to compute what's called a locator value. The locator, we take k over 100 times n, where n is the number of values and k is the percentile in question. Now there are two different routes to go. If when you find your locator, you get a whole number, then the value of the kth percentile is between the elf value and the next value. So you're going to find the elf value and the next value, and you're going to find the mean of those two numbers. If your L is not a whole number, if it's a decimal, you're going to change L by rounding it up to the next larger integer. The value of p sub k of the percentile in question is the nth value, counting from the lowest. Let's do two examples. First, let's find the 40th percentile according to the table. We're going to use our data from the previous example. So our first step is find that locator value. So L equals K, which is 40 in this case, out of 100 times the number of values in our table, which we know was 50. So let's calculate. 40 over 100, or 0.4 times 50, gives us 20. Well, is L a whole number? Yes. 20 is a whole number. So the value of the kth percentile is midway between the 20th value. So we need to find the 20th value and the 21st value. And we're going to find the mean of those two values. So let's look at our table. Note the 20th value is 11.6 and the 21st value is 11.8. So we need to find the mean of those two numbers. Calculate the mean, we get 11.7. So the 40th percentile is 11.7. Now, when we were asked to locate what number percentile 11.8 was, we got the 40th percentile. So note that you might get slightly different answers going in the different directions for percentile. And that's okay. Let's look at the next example. Let's find the 75th percentile. So we're going to find a locator this time that is 75 over 100 times 50. So 0.75 times 50 is 37.5. We need to ask ourselves, is this an integer value? No, it's not. So what we're going to do is we're going to round up to the next largest number, which is 38. And our answer is going to be in the 38th spot. You can see here the 38th spot has the number 21.5. So that means the 75th percentile is 21.5. You can write that P sub 75 equals 21.5.